but sometimes they are using aluminum as well. But predominantly we use steel. That too, the steel which has high wear resistance capacity. But if you are using any steel which has less wear resistance capacity, this failure can happen. Next is heat treatment. The heat treatment is that when we say okay, when you are going to boil the potatoes, we see if you are not switching off the gas stove at the proper timing, either it may be overcooked or it may be undercooked. So that where heat treatment. The same way, the heat treatment is one of the major processes. Okay. Here the case study is that the bus with the problem is in the transmission gearbox. So here the gearbox which is running hot have the excessive vibration. Okay. So excessive vibration. On that too, here the problem was with the 4th speed gearbox, not the first or second. It has to the 4th speed gearbox. So this is the natural appearance of the gearbox. Here you can see. So here you can see the pitting and spalling, right? Here you can see the breakages. So this is the breakages that has happened in the area, right? So when we take the before going to the gearbox, we have to see what is the value or what are the parameters that is actually happened at the gearbox. Here the helical gear has 36 gears, helix axis is okay, module of fixed circle, out diameter, inter diameter as per the standards. So the next thing what you are so this is the thing that we are going to measure with the manual or the measurement part, metrological part. The second one is the spectrum analysis. Spectrum analysis is nothing but we are going to find the chemical composition, or they are going to find what is the ingredient or what is the alloy which is actually present in the material of the particular gearbox. Okay. Here we have with the spectrum analysis we have taken that the gearboxes has the AISI 8620 or base system. Okay. Here the core hardness is 439, surface hardness 5. HV is meaning that it is the hardness value, that is Vickers hardness value, as we discussed in our classes. This is the Vickers hardness value, and this 413 core value, core and the surface is that for a gearbox this is the core area, the outer teeth area is the surface area. So compared to core, the outer surface should have the higher surface or higher hardness because the teeth is going to mesh with the other gear. So compared to the core, the surface should have the higher hardness. So here the case depth is 0.63. The microstructure is martensite with retained acid. So this is the okay. This is the one of the toughest microstructure for this gearboxes, for the gearbox materials. Okay. So this is the gearbox. This white color is the retained acid. This black is the martensite, which looks like a thorns with length. Okay, which looks like the thorns. Okay. So from the visual inspection is that it is due to fatigue. As I already said, the fatigue is the major, one of the major, failure that occurs at the high speed machines. Okay. Here you can see the rectangular base of the gear teeth has been broken, as I already indicated. Here the crack initiation benchmark. See the benchmark, this particular word is always synchronized with this fatigue. Okay. For the brittle fracture we have the striations. Okay. For the fatigue we have the benchmark. Okay. So for every failure structure, if we visually we see the failure area, we can see some defined structures will be there, defined patterns will be there. So with that patterns we can easily find out for an extent we can easily find out what type of fracture that happens at the failure area. Okay. Here the origin of the cracks was at the pitch line. So there is no correction media. The correction media, no correction media is found. It's because the gearbox will be running with the help of the fuels or oil. Okay, gearbox oils. So these gearbox oils will be running throughout the gearboxes. So there won't be any corrosion media. It's because the fluids what we are using, the liquids what we are using for a gearbox is not a corrosion. Will not create any corrosion. Okay. So this is the crack initiation part, and these are the benchmarks. Okay, these are the actual benchmarks. So you can see this is the crack initiation part. From there the crack has been made. Okay. Then the other thing what has happened is that it is a destructive pitting and spalling. Okay. The destructive pitting and spalling is that you can see large destructive pits in the failure. Okay, this is the pitting and this is the spalling. Okay, here இது வந்து ஒரு broken piece மாதிரி இருக்கும். இது தேய்மானம் கொஞ்சம் ஜாஸ்தியாக மாதிரி. So this is the destructive pitting area. This is the spalling area. Okay. So come